Here we're learning about logarithmic functions. Their graphs are actually in another lesson in another folder. So we're going to begin by finding the inverse of an exponential function. So we've already talked about exponential functions. So now we're going to talk about their inverses, which happen to be logarithmic functions. So an inverse is when you switch x and y. So I'm going to switch my x and my y. So I get x equals b to the y power. Now the problem is we can't solve for a variable when it's in the exponent because you're not quite sure how to. You can't take the yth root, you can't divide by b. So mathematically we're really kind of stuck at this point if we didn't have logs. So we know that 3 to the 2.5, so I'm looking at this problem right here. We could just plug that in the calculator and figure out what 3 to the 2.5 power is. Without a calculator it might be a little bit tougher. So how do we find x if I have 4 equals 3 to the x? So what power of 3 will give me 4? So I can maybe estimate here. So I know that if I had a 3 to the first, if my x was 1, that would give me 3, but I want 4. And I have a 3 to the second, that would be 9. So if I wanted a 4, I know that this exponent right here would have to be somewhere between the number 1 and the number 2. And probably a little closer to the number 1 since 3 is closer to 4. So I would know that my exponent would be about maybe 1.2 or 1.1. Again, we don't really know how many decimals. So that's the problem that mathematicians had, and in order to solve that, they used logarithms. So now if we take a look at here, this one, let's see, the log of x with base b is written the following, and you'll see right here it says log of x with base b. We typically read it log base b of x, log base b of x. B is a subscript. It's written below the word log. So the word log and x are the same exact size and they're right next to each other. The base is smaller and it's written below. It's called a subscript. And then that equals y. So let's see. Erase that. So for this problem, you're rewriting it. A few things that you can remember. The base of the log is the base of the exponential. So if you were to rewrite this, which we're going to be doing lots of, the base of the log is the base that has of the exponential function. And then x and y are on different sides than they were. So if b and x are next to each other, then they are not next to each other when you rewrite them. So let's see, the log of base 10. So we live in a base 10 society, so everything that we do is based on the number 10, so we have a digit system. So all of our numbers are base 10, so meaning that we have 10 digits that we use. 0 through 9. So that's 10 digits. After the number 9, we just reuse the same 10 digits. So the number 21 is really just using a 2 and a 1, which, again, we've already used. They're part of the 10 that we use. In any case, the log base 10 of x is written log of x. Now, it's understood to have a base of 10 in there, so we don't typically write the 10. It's kind of like writing x to the first. We don't write the first power, we just write x. So log x is just a base 10. And then a log with base e, which we talk about a little bit later, the log of base e is called the natural log. So if it looked like this, we would just rewrite that as ln x. And then we would understand that the natural base is e. Just to give you an idea of why we call it it's ln, because this is actually called the natural base, or the natural log. Again, it's just ln. It's on your calculator, so possibly you can evaluate them if you're asked to. So in these problems, we're just going to rewrite from log to exponential or exponential to log. So in this first problem, we have log base 3 of 9 equals 2. So the base of the logarithm is a 3. So when we rewrite that, that'll be 3, and then it'll have an exponent. Now remember, 3 and 9 are not going to be on the same side when we rewrite them. So that means that I'm going to have an equal sign, and 9 will be on the other side, which means that the 2 will fall into place as an exponent. So log base 3 of 9 equals 2 is equal to, rewritten in a different form, 3 squared equals 9. So for number 2, the base of the log is an x. X and 8 are separated when we rewrite them. So x8 separated out by the equal sign. And then that leaves the 3 to be an exponent. Again, we're just rewriting from logs to exponential because sometimes if you can't solve a log, usually you can solve an exponential function, and vice versa. So let's see, we have x cubed equals 8. Well, it says solve if possible. We can solve that. X would equal 2 because the cube root of 8 is 2. And the third problem, the base of the log is 4, and 4 and 64 get separated. And then x will be the exponent of the 4. So that's rewriting from log to exponential. Oh, I guess we can solve that one. X would equal 3 because 4 to the third power is 64. So now we're just going to find the exact values. This would be on a non-calculator portion of a test or quiz, and you should be able to do these fairly quickly. So a few things, I'm just going to maybe go down here at the bottom and do a bunch of different problems that kind of may help you to get the idea of this. So I would recommend that you write them down. So the first one I'm going to say is log base 2 of 2 to the 7th is just 7. Now, just write it down and maybe you'll pick up a pattern, and hopefully by maybe the 5th one you've picked up the pattern. So another example, log base 10 of 10 to the 8th power is 8. Or log base 6 of 6 to the, let's see, 3rd power, that would equal 3. Or log base, let's see, 8 of 8 to the 100th would equal 100. Hopefully you've found the pattern. The pattern is if the base of the log is equal to what you're taking the base of, and that has an exponent, the answer is just whatever the exponent is. So log base 2 of 2 is of 7 to the 7th power would just be 7. So it's really just essentially if you can get the base and what you're taking the log of to be the same number, the answer is just going to be that exponent. So let's go back up here to number 4. So I have a base of 5. So to make this easier, I'm going to rewrite the number 125 so that it's going to be of 5 to some power. Because if I have the base to be 5, I can make that 5 to the 3rd power, because 5 cubed is 125. And then that follows the pattern that we just did. So that would just be 3, would be your final answer there. For number 5, again, this has a base 10 because it's a common log. So I want to rewrite the number 100 so that it has a 10 to some power. So 10 squared is equal to 100. So we have log base 10 of 10 squared, so my answer is just 2. Number 6. Again, 1/5 I want to rewrite so that it's a base of 5. So I'm going to rewrite it as, you might take a minute to remember your negative exponents, but I'm going to rewrite the 1/5 powers 5 to the negative 1st power. Remember, you flip the fraction if you have a negative exponent. So now this one, now I have a base of 5, and I'm taking the log of a 5, so my answer is just my -1. Number 7 should be pretty quick and painless. It's already a base 4, and you already have a 4 to the 6th power. So your answer is just 6, just that exponent. Number 8. Number 8, again, it's already pretty much done for you. You have a base of 7. You're taking the log of 7. So your answer would just be your exponent of 4x. For number 9, This one looks a little bit tricky, but it's really just not. It's the same process. Remember, the natural log we can rewrite as a log. Let me erase this portion. The natural log right there, the ln, we can rewrite as a log base e. And then I'm going to just bring down the e to the 601 power. So ln is a log base e, and then I brought the other part down. So again, now it's that same situation. You have a log with a base e, and you're taking e to the 601. So your answer is just 601. So on the test, don't try to overthink some of these and try to do all this calculation because it's really not necessary. So for this one, you might have to think again a little bit if you're not certain of your exponents properties. So if I have a log base 8 of 8, I have to think of some power that's going to give me a 2. Well, it's not going to be a negative exponent because negative exponents would just flip the fraction, so you'd have a fraction. We don't have one. So it's going to have to be a fractional exponent. So you may not remember your fractional exponents all that well, but hopefully over the course of the lesson, the next couple lessons, you'll get a little bit better. So if I had 8 to the 1/3 power, the 1/3 power is the same thing as the cube root. Remember, you may remember from Algebra 2 that the 3 is called the index, and that's the denominator of your fraction. So here, your answer would just be 1/3. And number 11, I'm going to rewrite the cube root as very similar to what we just did, as 7 to the 1/3 power. That's because you have a 1. You have a 1 there as an exponent, and then the 3 is the denominator of the fraction. So we have log base 7 of 7 to the 1/3, so your answer would just be 1/3 again.